Hi everyone. Want to actually start a video with face to be like, "What's up? How you doing?" Just in case you're not seeing me. Um, Today we're going to talk about some new stuff in chemistry. I know it's been a while, so let's get right into it. Let me minimize my little face, that way it's not covering stuff up. So today is Lewis structures. It will be the YouTube link, which you're watching right now. Do now. So again, when this says on Pear Deck, if you're watching this asynchronously, if you're watching this right now and you weren't in class, like find somewhere to do the do now on today's document. Today's document looks like this. At the top, you've got like the first half of class. There's nowhere for the do now, so perhaps create a space up top, answer the do now questions if you were not in class whatsoever. So pause and think about these do now questions. Okay, the number of valence electrons, remember valence electrons are the outer electrons. Carbon has 1, 2, 3, 4. You also know it because it's in this column. And you might say like, oh, well, Murray, how do you know that this column's 4? Well, we always know the outermost column that's got all the noble gases in it, helium, neon, argon, krypton, all of these ones over here all have 8. And we can count down from there. We go from 8, 7, 6, 5, 4. Carbon's got 4. So that helped us answer the second question. How many valence electrons do the elements in the outline column have? Since this one has 4, this one's one to the right. We increase. All of these atoms, all of these elements have 5 valence electrons. They would look different from this because instead of saying C, they would say whatever element they are, and you'd be adding another electron to the outer shell. Note that in different rows, you'd have more orbitals on here, but we're going to stop really focusing on all of the orbitals and just pay attention to the outside orbitals today. Our last question, why does Murray say 8 is great? So we know that this carbon atom is not great yet because it does not have 8 valence electrons. 8 is the goal for most atoms to get 8 valence electrons, whether or not you're going to steal those electrons from somebody else or you're friendly and you're going to share your electrons. We're going to find out about that in this trimester about stealing electrons and sharing electrons. Last class, so we talked about 8 is great. I just talked about that. The final assessment, there's an answer key that is given to you on that assignment. So if you want to go back and look at it, like most people, I would say actually 50% of people did not pass about. It was a tough assignment and I designed it to be tough. And I think most people in chemistry ended up with good grades. Look back at that answer key, grade yourself and be like, what did I get wrong? What did I get right? I know some people have already sent me some stuff asking about that. Okay, important reminder here. So question I'm asking you here, folks, is why is this diagram important? How is this diagram helpful to you? So if you're wondering like, what combinations of atoms can I use to get to 8 valence electrons? Or if I want to know how many valence electrons over here in group 1 in our first family, I'd be like, maybe one of my elements over here and one of my elements from the 7, if those add up, those link up, we can get to 8. Or maybe even, what if 2 of our family 1 and maybe a family 6? Ooh, maybe not just thinking about 2 atoms linking up, 3 atoms linking up to get to 8? Maybe. Okay, this class, we're going to talk about bonding, talking about Lewis diagrams. Talked about Jake and Finn linking up, 2 atoms bonding together. Lewis diagrams. This is going to be our explanation of bonding, why bonding occurs. So you're going to take a second to pause and answer. What do you see? What do you think? And what do you wonder about this? So some things that I see are just like, we've got the element symbols, not the full names, like N, nitrogen, H, hydrogen. And here's the left-hand side where they're all like spaced out far away. And then they all come together nice and close. Nitrogen has got 8. Ooh, look at that. There's 8 electrons, 8 valence electrons around the nitrogen. We got something here called bonding pair and lone pair. Wonder what that's all about. Wonder why the lone pair is all by itself and all the bonding pairs are in between nitrogen and hydrogen. Those are things that I wonder. So we're going to get to a goal here by the end of trimester 2. So like the end of trimester 1, we were like using experimental data. We were trying to use that periodic table. We're trying to figure out like where atoms are and why they behave the way they do. But at the end of trimester 2, it's not just about one atom, it's about how atoms come together. So we're going to see how all of these things are related to one another. By the end of trimester 2, our goal is to be able to explain how all these are related together. So we got one sentence here. Iron and sulfur combine in reaction to create a new thing, iron sulfide. So we have two different elements combining in a reaction to make a new thing. Here we see another representation of the same exact thing. Iron, symbol Fe, sulfur, symbol S, combine, ooh, maybe the addition, to create, ooh, maybe an arrow, iron sulfide. Interesting. They're now together. And our third thing, like, ooh, seems like somewhat similar to what we have above, and our goal is to be able to explain this by the end. So if you're like, oh, it's confusing right now, well, good news for you. We still have 11 classes till you have to be able to explain that. So, along with these, we want to actually look at chemical reactions. This is the chemical reaction that I just put on the slide. This is iron and sulfur reacting together. Why do we want to explain these? I just think they're cool. I hope you think they're cool. I certainly think they're cool. Here's one reaction. Here's another reaction we might want to be able to explain. These are more chemical reactions. And our goal by the end of trimester 2 is to have enough chemistry vocabulary to be able to like point your screen at somebody and be like, show them your phone and be like, hey, do you want to know what's going on here? I can tell you. Wouldn't that be cool? And maybe our third one here. This is playing really loud in my ears. Interesting, interesting. So we're mixing stuff together. Oh my. Oh my, oh my. So if you're looking for more of these types of GIFs and you think they're interesting, you think they're cool, Reddit has r/chemical reaction GIFs. You can find more of those there. I'm sure that you've probably maybe seen these on Instagram scrolling, but if you want to find them in a just specifically them, you can go there. Cool. So now we're going to get to game time. What game time is going to look like today is going to our Google Classroom. We're going to open up this thing called collisions. You've got some instructions here on how to set this up. If you're cohort D, then you use this class link. If you're not cohort D, your thing won't say cohort D and there'll be a different class code. So for cohort D, this is the right thing. You're creating your account, shouldn't be too bad. So you're going to click join a class here. You've got the class code on this worksheet for today. This is today's worksheet, week 6, day 1. You're joining the class and it should have you to create account, security questions. I've already done those, so I'm not going to do that. After you log in once, you should just be able to log in with your Google accounts thing. So I did like log in with Google here. I'm going to pick my name and I'm pretty certain that just works after you do it the first time. If it doesn't, that is why I have a spot for you to write down your username, and I'm telling you what to make your password. Make your password exactly this, Chef Murray, 1 exclamation point. That way, if you're ever like, Murray, I forgot my password, then I'd be like, yo, I know exactly what it is. You've got this thing here. You got 8 levels here for this thing called covalent bonding. I'm just like opening up to level 6. You'll like, I'm just showing you an example of what we're doing here. You're going to be like given atoms, and you're going to have to like drag them around, move them around. I'm going to reset this real quick. For example, you're going to like have atoms up here. So you're like carbon. Oh, I need a carbon atom. Hydrogen, I need a hydrogen atom. Oh, I got 2 hydrogen atoms. I got fluorine atoms. Okay. And I want to be able to combine all these things together. And you better be able to move around the electrons. You're going to be able to decide like, ooh, what do I want to bond together? Ooh, do I want that to bond together? Is that what I want? Ooh, but you've got a goal down here. You want to make this thing. There's a shape down here, and it's going to direct you on how to make it. It's pretty self-explanatory. What you definitely have to do is get through 8 questions and the 8 levels, levels 1 through 8. and you have to answer these 5 questions. If I see that any of these are blank, you won't receive credit for the exit ticket today. So take a second. You need to go to your Google Classroom. Your Google Classroom has a link to this. It's called Collisions. The link looks like Collisions. You play levels 1 through 8. You answer these 5 questions. So right now we would typically take a pause. I'm going to go to level 6 to show us something that I thought was important. Wait, not level 6. I wanted to show you level 5, maybe. Yeah, so right here, when we were doing this, we were saying like, okay, we've got a carbon atom here, and it's got 4 valence electrons, and we want to make carbon great. So if we want to make carbon great, one thing that we can do is attach hydrogen atoms to it, because hydrogen atoms all have got 1 valence electron. Wouldn't it be great if they could just share? They just snap onto each other. Look at that. So we like move the valence electrons. We got to make sure they line up. And oh, if we line all of them up, look, they all line up here. Carbon is happy here in the center because it has 8 valence electrons. Hydrogen actually breaks the rule. Remember how I told you about the 8 is great rule? Well, hydrogen is special. Hydrogen breaks the rule here. So carbon is happy. It's got 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. Hydrogen's happy because it's given its 2, it's sharing 2 with carbon. So that's just one thing that I wanted to go through real quick. You've got some time to pause and take down some vocabulary. You've got valence electrons, chemical bond, Lewis dot structure, octet, duet rule. You've got here a chance to pause and get these down. Again, I'm not going to, you need to have this down in order for me to like look at your exit ticket. If I see just like bunches of blanks here, I'm just going to return this to you and say like, hey, you left this all blank. I'm not going to look at your exit ticket until you fill out the your notes. Okay, so we've got vocab section here, a vocab section here. You can pause the video and get these down. And our big rules for today is that 8 is great and that 2 is glue. This is specifically for hydrogen. 8 is great is specifically for, or not specifically, more general for all the other atoms. Reminder that the number of valence electrons is really dependent on the column, the vertical column. So when we're doing a Lewis diagram is the symbols and dots you saw. So we have to use an element symbol. We have to get the valence electrons. Then we have to draw some dots. Let's do this. We're going to use an example for bromine. Bromine has the symbol Br. Br is in the 7th column, therefore it has 7 valence electrons. I draw 7 dots. So here is my periodic table. I know that the one all the way on the right-hand side of the table's got 8. So I go 1 over. That means all of these have 7. So these all have 7. So that means I need a Br in the center. And I need to draw 7 dots. So I got 1, 2, 3, 4, 5, 6, 7. Looks like I am done. I am happy. This bromine isn't great, but it's Lewis diagram. A Lewis diagram just for the atom. I'm not talking about making it great yet. That is when we get to bonding. The Lewis diagrams for the atoms by themselves, it's a difference in bonding. So this is on your slide. If you were in Pear Deck, you'd be drawing. So my suggestion to you is to get a piece of paper, get a pen, and try to draw the Lewis diagram for nitrogen. You want to start with its symbol, which I've given you as N. You need to get its valence electrons, then you need to draw the dots. So pause and try that. Okay, so nitrogen has symbol N. It's in the 5th column, so I draw 5 dots. Nitrogen's right here in the 5th column. The box gave it away a little bit. Well, it didn't really give it away. You were trying this beforehand. So symbol N, got that. Valence electrons, no, it's 5. It's in this column right here. 8, 7, 6, 5 right here. So I got to draw 5 dots. 1, 2, 3, 4, 5. Something that we're noticing about the pattern here is that there's only like 4 spots for the dots. They can only be like 1, 2 here, 1, 2 here, 1, 2 here, and 1, 2 here. You can't just draw 3 dots on top. If you did that, that's not right. You need to have, at most, be able to pair them up in sets of 2. Okay, now you're going to try this for boron. So something that we're going to see similar here. Boron is now in this third column. So 8, 7, 6, 5, 4, 3. So it's got 3 valence electrons. So I need a B and 1, 2, 3 valence electrons. Notice that nowhere am I extending above 2. Right now, these are all unpaired electrons. They're not buddy up with each other. They're just chilling by themselves. Don't really worry about the chilling by themselves. It's not really important right now. Here is our challenge part. So we're going to try and draw a Lewis diagram for Br2. That's 2 bromines that are bonded together. Here's bromine. So again, the first 3 steps are going to be the same. You're going to get the symbol, you're going to get the valence electrons, you're going to draw the dots. But note that you've got to do it for 2 bromines now. After you draw for the 2 bromines, then you're going to change some of your dots to lines to indicate that the electrons are bonded together. The electrons are bonded together. So what does that look like here? So what does that look like is like, okay, this is me doing it at first, being like, okay, I got 1 bromine here, I got another bromine here. Interesting. They each have 7 right now. They're not great. But wouldn't it be cool if they could each share these electrons? So let's add them together. We're literally taking the bromines and moving them close together in space, just like we saw in the game. And then they make this thing, ooh, 1, 2, 3, 4, 5, 6, 7, 8. Ooh, looks like bronine's happy. This bromine over here, also happy, also has 8 valence electrons around it. They are sharing these electrons right here. So instead of drawing it like this, we're going to, again, change dots to lines to indicate bonded electrons. They started as dots. Now it's a line to indicate these 2 electrons are bonding. They like dap each other up and they're like holding on to each other now. That's why these 2 bromines are bonded together. Okay, so for your exit ticket, since you're not on Pear Deck right now, drawing is going to probably be on a piece of paper, or there's instructions on the Google Doc. So you've got some questions right here, which you're not going to answer right here. You're going to answer right here. So this says make a Lewis diagram for a calcium atom. You are going to need to use the periodic table to do that. You've got to be able to explain if this is a correct Lewis structure for carbon. And then you've got to decide which of one of these is correct and explain it. How do you know? You got to explain it here. That's why there's a big box here. Don't just say like left or right. Clearly, I'm giving you a big box to explain it. I'm going to make that neater there. So one thing that if you want to do this for a calcium atom, one thing you can do here, I'll show you, is you can take this. Once you click it, it's like highlighted. And you can copy that right there. And then you can paste it here and be like, okay, well, Murray, why'd you do that? I'm going to show you why I did that. Because obviously this C is not going to be right, because considering that we're going for CA here, we can double click this and it brings up the drawing that I did. When it brings up the drawing that I did, you might say like, oh, like, interesting. I'm starting with C. How can I change this to make this correct for calcium? You can like click these dots and delete them or add as many as you need. And once you like save and close it, I'll show you like me editing it. Here is me like just deleting all the things. And I'll just say, I'd be like, oh, I think calcium is a C with 1 dot. That's obviously not right. But just to show you, look, boom, it edited it there. So again, what you do is you like click this, you copy it, and then you paste it into here, and then you can edit it. So you can like, I could edit this one right here, and by clicking on it, double clicking on it. Or if you click it, there's the edit button. If you're like, Murray, that didn't make any sense, there's a YouTube video on how to do that. Also, if you're like, I don't want to do any of that, you can draw it on a piece of paper as long as you like make it dark for me to see. Take a picture with it on your phone and then insert it here. Totally fine with you doing that. Lots of different options for the ways that you want to draw. I know that drawing is not the easiest thing to do on a computer, but it's like really important to chemistry to be able to draw, unfortunately, but that's just how it is. Again, I'll remind you that this exit ticket, I'm not grading it if I see lots of blanks up here in the definitions and if I see blanks up here. If you just turn in the exit ticket without doing all the other work, I'm not gonna grade it. I'm not gonna like say, oh yeah, you didn't do any work and you just did the exit ticket. Nah, dog. You gotta do the work in order for me to grade it. I'm gonna stop my share. Deuces. See you later.